Hi and welcome to my new video. Today I would like to illustrate the blog post about commands, which is linked in the description of this video. So this is my demo code. In this code I'm using a Hive Metastore to interact, to create some tables, to add a new columns, and also to show all tables that are present in the catalog. So in the demo I will have three metadata commands. The first command will remove the table in case if it already exists. Later on I will use an alter table and I will also print it output to show you the purpose of a field which is called side effect result. And by the end I will do exactly the same thing, but this time I will call the show method, and I will also do some writing for the output of show tables command. So let me run the code in this debug mode to see what happens, and I will also add the breakpoints to some important methods. So yeah, we start with this drop table, and as you can see we will come very soon to drop table command. Yes, that's the case. So here you can see the physical node which is responsible for executing, for running these metadata commands, and this physical node is shared, it's the same for all metadata commands, and it's called execute command exec. As you can see, it takes the command in parameter and later executes its run method inside this side effect result field. So here I will not explain it yet, but I will do that just after, when we will go to this alter table statement. So here I will add a new column, and you can see that I'm calling the show method on top of the data frame which is returned by this alter table column. An important thing though is that this alter table command will return an empty data frame, simply because if you check the implementation you will see that the output is inherited from this command thread and it's empty. It's not the case for show table command, because you can see that we are defining concretely some schema that will be later used to map the output of the run method and to return it to the client. But anyway, let's go back to this alter table. So that's the first execution currently, and here we will run this side effects result anonymous method, and in this method will produce the value stored in this side effect result variable. And it's quite important because this the name side effect here is not a mistake, is on purpose, because thanks to this variable Apache Spark will avoid to recomputing the same execution once again for the given data frame. So for the given data frame, it means that if I run this show method, I will not re-execute the run. Instead, I will simply take the side effect value. But if you will see that in the second part of the demo, if I run this command once again, it will re-execute the command twice, and in consequence it will fail because we cannot add the same columns twice. So here we are going, and you can see that it will not go to this run method. Yeah, so this one is currently for another, because you can see that we are going to show table command, and I simply forgot to add the breakpoint here, but anyway this debugging applies to this part, not to this alter table. So you can see that we should already showed something, not yet, but we will do it very soon, because yes, now we are running the query and we are mapping it to some to the output format of the show tables, and you can see that we have the tables. But the important thing, yes, is that for all the commands that are executed previously, Spark didn't schedule any job because they were executed locally with the meta store on the driver. Whereas you can see that when I want to output, I want to materialize the show tables data frame, obviously I will do it with a Spark job, and it's quite normal. And it's normal because the writer we are invoking here, we are calling here the writer API, which is obviously executed as a job and scheduled on the cluster. And so as you can see, there is no difference between the type of the data frame you use for that. If you use the data frame which is maybe some Kafka data or some JSON input data, or the metadata information retrieved directly from the meta store on the driver. So now I would like to show you another point. So this time you will see that this side effect applies only to the scope of the data frame. So only to the scope of the SQL and to the data frame that is returned by this SQL. So it means that if I would call it this 5 or 6 times, I would never recompute this alter table statement. I would always use the side effect results. But you can see here that I have exactly the same statement, and here Spark will re-execute it, rerun it, because it's a new data frame for him. So let me just demonstrate that by running this code, and obviously it will fail because, as I said before, we cannot add 2 columns having the same name to the table. So yeah, here we are starting with our drop command, which is not important for our case here. Now we are doing still the drop, the save, okay, as previously. And yeah, that's still the save. And now, yes, now we are doing the alter table. So the first time you can see we will run the command. So we will physically add this new column to the table. And that's also one specificity I have forgotten to mention, is that these commands, unlike Apache Spark data operations, are eagerly executed, meaning that they execute as soon as you write them in the Spark SQL method. Unlike, as you know, for the data operations, Spark will wait to see the writing action before materializing, before reading the data and processing and starting the processing job. So here we are doing the alter table. That's the physical execution of the run, and now we are doing it the second time because we are doing the show, and you can see that it's not re-executed, meaning that we executed the alter table only once, even though we are using this output alter table multiple times. As I said before, this side effect result behaves a bit like as you call like Apache Spark cache, so that it's not re-executed every time you use it. But now you will see that we have the same operation, but we will run it physically. So you can see that we already entered to this SAMD run, and as expected, we have the failure because Spark found some duplicate columns in the user list column. So I would like to summarize this commands feature. There are some few things to know, to remember. So the first one is that it has some side effects, meaning that it operates on some external metastore which is mutable, and to avoid these side effects like we could see here with the alter table, it introduces the concept, this lazy variable which is called side effect results, that lets you to use the outcome of this operation without executing it multiple times. Of course, this cache remains scoped is scoped only to the data frame. It's not scoped to the operation. Spark will not remember that you already have done this alter table and take the result from the cache. No, it's quite straightforward. It will simply rerun it, and it's your responsibility to know if you have done it before or not. The second thing is that these commands are eagerly executed, meaning that you don't need to do the show or any action on it in order to trigger them. You saw it, by the way, previously here when we have done the drop table. Remember, it was executed physically as the first command. And I think that's all for this. Yes, this last part, quite important part, is this part of the write. So the commands, even though they execute on the driver and they interact with metastore and return very probably very small data frames, they can be used with Spark API, because after all, the SQL outcome is a data frame. So you can use the write, you can use the collect, you can use count, anything you want, and physically behind it will obviously trigger a new job. And yes, that's all for this demo. There are some much more details in the article, which is linked in the description of this video. I also tried to cover the differences you could observe regarding the commands and the physical data operations. And if you are curious about these differences and some much more details that I extracted from the code source, I invite you to this article. You will find the link in the description of this video. It was Bartosz Konieczny from 1key4code.com. Thanks for watching.